Hey guys, Mr. Holly. There's one more thing I really think we need to explain here when it comes to angles, and that is vertical angles. We have not had a discussion about vertical angles yet, and I want to create this video to simply focus on vertical angles, and I'm going to pull them out of this classifying angles worksheet that you should have. Okay. Whenever we look at number 2, what you'll notice is that you have two lines that are intersecting. Anytime I have two lines that are intersecting, I have this unique scenario where I've got supplementary angles here and supplementary angles over here. Each angle pair creates supplementary angles. These two would create supplementary angles. In addition, these two would be supplementary angles. So I've got two intersecting straight lines. Now, when this happens, there's another angle relationship that happens. That angle relationship is called vertical angles. That means they are on the opposite side from one another across from the intersection. So at this intersection, I've got an angle up here of 119 degrees, and then I have an angle directly across it. Well, if you look, and if I had like a mirror here, we could just reflect this. We could reflect this angle right over the intersection, and we would see that this angle is actually identical to the angle below it. These are vertical angles, and they're going to be identical to one another. They're going to have the same exact angle measure. So, as we explain that, then we really would have no work here to find x. We would just say that these are vertical angles, and because they are vertical angles, x would have the same angle measure as the angle across from it, 119, or I guess x equals 119, and we would write vertical in this space. Now, we could also go through the process of looking at supplementary angles and then determining the measure of x. If these angles are supplementary, then if that's 119, well, 119 plus 61, that would make that 180, right? But the reason, and another way to prove that these are going to be identical is, well, not only are these two supplementary angles, but these two angles are supplementary angles. So 119 plus 61 is 180. Well, 61 would have to be added to 119 to create a 180 degree angle on this side. So what you're really seeing here is these two angles have to be the same because they both share this angle and they both create a supplementary angle pair with that angle. So they have to have the same exact angle measure. Here you've got an instance of vertical angles, but we are not solving for the vertical angle. But look at like number 8. If this angle is 59 degrees, it's at the intersection of two straight lines. Well, this angle over here would have to be 59 degrees. We see another example of vertical angles on number 8. Even though we're not asked to solve for this, we're actually solving for this supplementary angle here, and I'll let you do that on your own. Let's look over here at the back side. There are two really good vertical angle questions on the back side here, and I will go ahead and do one for you. Question number 14, I see that these two lines are intersecting. I have two angles across the intersection from one another. That means they are equivalent. So I can create an equation here. This equation would be 80 is equal to this angle measure of 2x plus 10. Now I can subtract 10 from both sides of my new equation. And I would realize that when I divide by 2, x is equal to 35. Let's see if it works. What if I take 35 and plug it in for x? That'd be 2 times 35 is 70 plus 10, that's 80. Those are equivalent angle measures. X would have a value of 35 if I was solving for x. Okay? So guys, these are vertical angles. It is a skill that, or another vocabulary term, another tool that we need to have in our knowledge of angles, so that we can, in this case, use them to solve equations. All right, thanks.